Hello student, welcome back to my pre-video lecture of number 7, minimization of DFA. Today pre-video will be discussing on minimization of DFA. Minimization of DFA is one of the most important. So far you have learned construction of DFA, construction of NFA, construction of epsilon NFA. But we are not predicting a number of how many number of states are required to construct a particular device or particular machine. So but at the ultimate, at the end, we have to see that how minimal DFA can construct. This is so that is very important. So any machine, it should be work in an optimal way of computation and time complexity. Sorry. Right. So for that, you need to reduce the number of state. Someone has constructed same language using a 10 state, and some other fellow has constructed DFA by using a 5 state. So which is the best DFA for that among these two? So who has constructed DFA by using a 5 state is the most minimal DFA as compared to the other fellow who constructed by 10 states. So that's the reason you need to reduce it. Okay, so that means it contains the minimal number of states. DFA needs a minimal param is called as a minimal DFA. So how to minimize the DFA? DFA is not possible to by eliminating by seeing a state, but you have to follow certain rules. So that rules is nothing but techniques. There are two techniques are there. There are two popular techniques. One is equivalence theorem or Mahil-Nerod theorem or table filling method. These two methods are very important for minimizing a DFA. Right? Let us see the first theorem. So first theorem is equivalence theorem, which is using for minimizing a DFA. It's also called as a partition method or iterative method. First you need to follow some certain steps. Okay, step number 1. Is there any dead state? You need to eliminate, and also you need to remove inaccessible state from the given DFA. What do you mean by dead state? Dead state is all those non-finite state which transit to itself for all input symbol in sigma are called as a dead state. What is inaccessible states? Inaccessible states, a state which can never be reached from one initial state, are called as a inaccessible state. Right? So that means in order to reach any state from initial state, those states are called as a inaccessible state. Step 2, you have to partition it. We will divide given set of state into two sets. One set will contain final state, other set will contain a non-final state. This partition is called pi, and finally these two sets is assigned to pi. Step 3, compute pi new from pi. Right? Step 4, so you need to once obtain the pi new from pi, then you have to compare these two, pi and pi new. If both are equal, go to the step 5, or else it is both are not equal, go to this. If both are equal, go to the step 5, or else you'll get inside the loop, assign whatever there is in the phi new to pi, right? Then repeat step 3. Then what is end if? Then go to step 5. Go to step 5 is pick the representative from each group. This representative becomes the state of the reduced DFA. Okay, so this is the major step we have to follow to minimize the DFA of equivalence theorem. right? That is a one note is there. All those states which belong to same set are equivalent. Suppose there are two states are belong to same group, then both are equivalent. So you cannot be make separate. You are so cannot make the separate. You merge them. Okay. These equivalent states are must to form a single state in the minimal DFA. Right. Now we take the, so as I said in the previous slide, there is a step number 3. There is how to construct a phi new from pi. How to construct a phi new from pi? You need to follow the separate procedure. That is procedure to construct a phi new from pi. Again, step number 1 in this, you have copy whatever there in the pi to pi new. Then for each A, so A is a input in sigma do for each subgroup G in pi. Then find the transition for each input symbol in subgroup G. So for that, Q in G on input symbol A, you may get the states are like this. Suppose Qi, Qj, Qk, Ql, Qm and Qn are the states in subgroup G, and Pi, Pj, Pk, Pl and Pm and Pn are the resulting states on input symbol A. Right. If Pi, Pj belong to one group, Pj, Pk belong to another group, and Pm, Pn belong to some other group, then partition the subgroup G into groups consisting of Pi, Qi, Ql, Qj, Qk and Qm, Qn. So you have to partition like this. So once that partition is done, so this rope will be continued to rotate until this pi and pi new are equal. So end for first loop, for loop, end for second for loop. At the end, whatever you are getting in pi new will assign to pi, copy the final pi to pi new. Right. Now we take the problem. So once you understand that, so procedure, then you can use those procedure to minimize the given DFA. Okay. So this is the one diagram I have taken. Look at this diagram. Is there any day state or inaccessible state? Then you have to check those. Definition of that step 1. Is there any day state? So there is no day state at all, because given diagram you can able to reach every state by given in from starting state, and also accessible from starting state, and there is no transit itself, so such state is a dead state. So in that case step 1 is directly right. There is no day state and inaccessible state from the given DFA. Step 2. So step 2 says partition the given Q, capital Q, into two set. One set consisting a final set, another set consisting a non-final set. In this, what are the two set? So I will take first set number 1. So one set consisting a non-final state. What are the final state? Q0, Q3, Q5. Then now what are the final state? Q4, Q1, Q2. So let's see that. We will divide the given set into two sets, one consisting a final, other one consisting non-final. Then this you will get it. Right? All blue colors are so non-final final states, and red colors are non-final states. That is assigned to the phi. So then step 3, you obtain pi new from pi. Right? So now in this set we consider both the groups, since contains more than one state absolutely. So find out the transition on each input. First you take the first group Q1, Q2, Q4 on input symbol 0 and 1. Find out the transition. Delta of Q1 comma 0. So Q1 comma 0 it will go to Q2. Q2 comma 0 will go to Q2, Q4 comma 0 will go to Q2. Similarly, you can find out on 1, right? Delta of Q1 comma 1 will go to Q5, then Q2 comma 1 will go to Q5, then Q4 comma 1 will go to the Q5. Now you have to find the decision you can take it. So you have to find the transition. Then you have to look at this color coded, blue color coded resulting sets. So this resulting set, okay, is all this resulting set Q2 and Q2 are all belong to one specific group. What is that specific group? Q1, Q2, Q4 is a first group. These resulting states are belong to one specific group. There is no partition it. Here also you can see the second group Q5. The resulting states are all belong to one specific group. Look at this second group. Then there is no partition. Look at that. I have written here it is no partition. Why that is not partition? Why not partition? The obtained resulting states are not distinguishable. Okay, all are same. So all are same. So it is not possible to distinguish. Okay. Similarly, consider the second set. So set Q0, Q3, Q5 on input symbol. Similar way can be find out the transition. Q0 on 0 will go to Q3. Q3 on 0 will go to Q0, and Q5 delta of Q5 comma 0 will go to Q5, and similarly on 1, Q0 on 1 will go to Q1, Q3 on 1 will go to Q4, Q5 comma 1 will go to Q5. Look at this first group. So this Q0, Q5, Q0, Q5, Q3. So look at this, right? This is belong to one specific group. That means it is all resulting states are not distinguishable, no partition. Look at in other side of these resulting states are not distinguishable, so no partition. So look at in other case. Here it is Q1 and Q4, right? Q1 and Q4 is belong to first group G1, and Q5 is belong to G2. Then definitely the resulting states are distinguishable. Resulting states are distinguishable. Then I have to do the partition. How to do that partition? These two become one group. This is will go to the another group. Look at that. Pi nu is the Q0, Q5 on input symbol G1 or Q1, Q5, Q1 respectively, which are different set in a partition. So then what is pi? So Q0 and Q5 are distinguishable. Then Q0, Q3, Q5 will be partitioned into Q0, Q3 and Q5. So now it is what is pi? The pi is, I'll go to the next. Pi is pi nu is equal to, so there is a first case. The first case there is no partition. I have written as it is. In this case you have partition it, then you have written this, right? So Q0, Q3 and Q5. Now there is a pi nu got 3 set and pi has got 2 set. So step 4 is says, step 4, to compare both pi and pi nu, both are not equal, then go to step 3. So before go to the step 3, assign pi nu to pi. Assign pi to pi nu, pi nu to pi. So now pi becomes 3 set, pi nu becomes empty. Again step 3 is obtain pi nu from pi. So copy that. I'll take the first set. So Q1, Q2, Q4 on input symbol 0 and 1. So you all get is Q2, Q2. On 1 also Q5, Q5. Now you see that the resulting set of states are all not distinguishable, then no partition. Take the second set on input symbol 0 and 1. So take the transition on this. Q0 on 0 will go to Q3. Q3 on 0 will go to Q0. and also q delta of q naught comma 1 is go to q1, q3 comma 1 is go to q4. So find out the decision here. So q3 q naught q3 is in belong to one specific, q1 q4 also belong to one specific group. So obtaining resulting states are not distinguishable. Then what is the condition here? No partition. Then there is no partition, so no need to partition it. So third set. Now third set is, since we have only one state in this set, it cannot be further partitioned, so no need to consider. What is the phi nu now? Phi nu is 3 set. So they have not, in this second step, in this repeating step of step 3, you have not done any partition, then you retain pi nu as it is. Then you have to go to the step 4. Step 4, you have to compare both a pi and pi nu, both are equal, then go to step 5. So what is step 5? Pick q1, q2, q4 are states merge into 1. Similarly, q0, q3 are merged into 1. Minimize DFA corresponding to this. Look at this. I have taken this one set, right? This is 1. Then q0, q3 is belong to another group, and qp is belong to other group, right? So this is a transition diagram as merged. So when I started reducing earlier, then the given DFA there are 6 states. Now you reduce to 3 states. This is the one method you can reduce the minimization of DFA. So we can do some more problems. This is the best example I explained through this pre-video. We'll do 3 to 4 problems in the classroom on the board. Thank you guys. We'll see you in the next pre-video on 8th. Thank you.